Hello everybody. This is the third and final notes for section 4.1 calculus. Talking about some ideas that you're going to see in story problems. So what we've talked about so far is just really the quick way to find the derivative. Doing some applications of that, setting the derivative equal to a certain number, because the derivative is the slope of the tangent line. So if we want that slope to be a certain value, find the derivative, set it equal to that, solve for x. In some of these story problems that you're going to see, you'll see this quite a bit, this demand function. What that does, demand of an item is how many things that people want to buy or are willing to buy. But it relates that number, how many items people are willing to purchase, to the price. So the value of P is the price, Q is the quantity. Sometimes it's solved for P in terms of Q, sometimes it's Q equals something in terms of P, but that's what we're looking at. So, we've talked about this term before, marginal. Basically it means a rate of change, so we're talking about marginal profit, marginal revenue, marginal cost. It's just a rate of change. And so that's really what the derivative is a rate of change. So when we are asked to find marginal something, we need to find the derivative. All right, so let's look at this example. It says the demand function for a certain product is given by this equation. So again, the value of P is the price of the item. This value of Q is the quantity, how many of these items. So now, the question says, find the marginal revenue when Q equals 10,000. This is a demand function. This is not revenue function. Revenue is the number of items that are being sold or people are willing to purchase, multiplied by how many items. So the price at which you are willing to pay multiplied by how many items you are willing to, people are willing to buy. So what we have is this value of P is the equation. That's a 50,000 minus Q over 25,000 times how many items. Okay, key thing here is this revenue is the price multiplied by how many items. That demand function is the price of the item at a certain number of items multiplied by how many items. So what we're going to do here is, in order to take the derivative of this, because again the question is what is the marginal revenue, and so if we're going to find the rate of change for the revenue, we need to take the derivative of this. Now with what we've talked about of finding the derivative for a function, we need this to be in terms of the variable, powers of the variable. So what I'm going to do is try to manipulate this demand function first. We got two terms in the numerator being divided by 25,000. So I'm just going to divide each term in the top by the 25,000. That just gives us 2 minus 1/25,000th Q, and then we are multiplying by Q. So now distribute that Q. We have 2Q minus 1 over 25,000 Q squared. This is our revenue function. It was the price multiplied by how many. And so now we're going to find the marginal revenue at 10,000. So that means we need to find R prime. And everything is in terms of Q. So we're taking the derivative of R with respect to Q. Derivative of each term, derivative of 2Q is Q minus, bring that exponent for the second term out in front. So we really have 2 of these 1/25,000ths, and then decrease the exponent by 1. So this is our marginal revenue function. It's the derivative of the revenue function. What the question is asking is, what is the marginal revenue when the quantity is 10,000? So marginal revenue is our derivative function, and we are plugging in 10,000. So we got 2 minus 2 over 25,000 times 10,000. 2 minus 20,000 over 25,000, which is, oh boy, well, 20,000 over 25,000 is 4/5. So what we're looking at, is that right? 5,000 is a common factor, yeah. So 2 minus 4/5 is 6/5, which equals 1.2. So if these are, didn't really define price here in the equation, let's just make this to be dollars. We're making $1.2. The revenue is $1.2, or $1.20 revenue per item. We're making $1.20 per item. Okay, that's the idea of marginal revenue. How much the revenue is at, per item when we're making this many. It's 10,000 items. All right, that is it. You'll see some different types of story problems with different contexts, but this is the idea. Sometimes you're not given the function, you're given a demand function, and you're asked about revenue. So you got to think about what is the connection between those. And that was where we got this equation from. All right, bye-bye.